So next talk would be Javier Serrano. He's a physicist and electronics engineer and the leader of electronics and low-level software team in the BIMS department at CERN. He's a fervent advocate for open source and, among others, the co-author of CERN Open Hardware License and the creator of the Open Hardware Repository, a platform where institutes, companies, and individuals can freely share their designs. So, Javier will talk about best practices to open source FPGA design.
Thank you. So thank you to the organizers, Davide, Francesco, Eva, and all the other in the committee and the rest of the organization for this nice event. It's a great pleasure to be here to talk about best practices to open source FPGA designs. I should start with a quick disclaimer. Sometimes these things are a bit subjective. I'm trying to discriminate between the things which are not controversial, the concepts, and then the implementation, which uses tools which are a bit more to the taste of each one of you. So hopefully you can get useful information out of this presentation. I should also say that some of the material is CERN specific. I gather many of you work at CERN or with CERN, so that material will be directly relevant. If not, I hope this illustrates issues that you have to grapple with anyway in your particular context. So it will make you think of it. So first of all, open sourcing things takes time and energy, so you probably do it for a reason. It's important to know the reason. Here I list a few possible reasons. You look around, people who you know work on the same things as you, and you get this feeling of frustration that everybody's trying to do the same things, and it's not very motivating to be working on things that other people are already trying to solve. Maybe you would like to focus on something instead of trying to do everything, doing one thing and doing it right, and relying on other people doing the same and using their work. So in the end, you get higher quality. Maybe, like in the case of CERN, your organization or your company has this mission of sharing with the rest of the world and having an impact. I mean, CERN doesn't have directly this mission of open sourcing, but it does have the mission to have an impact and to distribute what we do. Open source is one way of doing it, which is very efficient in the case of software, gateware, as I will explain, and also hardware. And finally, maybe you just want to work with other people outside or inside your organization and learn from them as well. And open source development is a very nice way of doing that. Okay. So what is the object of the open sourcing? Obviously the gateware, the HDL of your designs. Maybe you're publishing a single core, or maybe you're publishing a complete top-level design. Then accessory or auxiliary files that will make it easier for people to use your work, like the documentation typically, including things like your strategies for reset and clocking, test benches, of course, and then scripts to generate proprietary files. This is very important. You don't have the right to put proprietary files online. Those are all rights reserved. So whenever you produce something locally and it has this header, all rights reserved, you should not put it online. Rather, you should publish a script which will allow people to reproduce these things locally. Okay. Also to generate project files. Project files are not very Git friendly because you change a little option and the change in the file can be very complicated. So better to publish a script that generates a project file locally. Hardware, because your designs will typically be will configure an FPGA that will sit in a piece of hardware, and that hardware, it would be nice to describe it. Details of interest, like power sequencing, description of the different IOs, quantities, types. And finally, on that hardware, you will have your design hopefully running, and it would be nice to provide a reference design, one or more reference designs, so people start building on a working system and then modify it and keep it working all the time. Whom you should involve. This is CERN specific, but in fact, in your own context, you should work out what the sequence should be. At CERN, it starts with your design team and the community around your design. You discuss and you figure that you want to open source. Then you discuss with your line management and you go together to KT. KT is the knowledge transfer group. When you have an agreement that open sourcing is the way to go, then there's something new, of which we're very proud at CERN. Somebody is going to help you do it right. So you've decided to open source, and a group of people at CERN has this mandate of helping you do it in a correct way, in an efficient way. And that's the OSPO, the Open Source Program Office. At CERN, the Open Source Program Office has it in scope to help you with software, but also with gateware, HDL, and also with hardware, okay? PCBs, mechanical designs, etc. And then when you have this assessment with the OSPO, you discuss about licensing, about how you want to go about it, the platform you want to use for sharing, and so on, all these details. You go back to your line management for a final confirmation on open sourcing. When? So you should not go public before doing something called due diligence. I provide a link here from the CERN OSPO documentation, which explains a bit what due diligence is about. It's about figuring out if you're on a legally sound setting. So do you know all the copyright holders for your HCL? Are they okay with the licensing that you've chosen? Do you have dependencies on other blocks? Are the licenses compatible with one another? All this together is called due diligence. Okay? You should not go public before doing the due diligence, and the OSPO can help you with that. KT as well. And then also not before the final okay of the line management, as I showed in the previous slide. Then, once you have the okay, two possibilities. Open when ready. This is for people who say, I don't want to be bothered with questions while I develop because it's not finished and they ask obvious questions that I'm going to fix anyway. It's bothering me. Or open from the start, which has this disadvantage of getting maybe more questions, more comments, some of which might not apply, but it also has the advantage of pulling in people's interest, maybe new contributors, maybe relevant comments. So this is the option we prefer, open from the start. Okay, and then going into the heart of the talk, the how. First of all, about your project. So it's in the best practices of open source to not reinvent too much and to capitalize on past efforts. And similarly, when you think about open source HDL, you also try to see if somebody has gone through these things. And it turns out that the free and open source software world, which has been extremely successful, has already figured out a number of things that apply directly to HDL design. So let's reuse them. Let's learn from that. First of all, modular designs. When you have a problem to solve, try to solve some more general problems in the way. Try to break down your problem into manageable pieces of logic which are reusable. Okay? And then, in doing so, try to populate, try to enrich a common kit which might not only be yours. You can start locally, but hopefully these are things that everybody needs. Memories, FIFOs, ways to safely cross clock domains. Not only everybody uses them, but the fact that somebody focuses on them very, very hard will make them higher quality than whatever you could do on your own. So try to build this common kit. I think this is one of the goals of this forum. And then also one thing we learned from free and open source software is the value of good, robust, well-documented interfaces. And then hiding technology-specific blocks like transceivers for a given FPGA vendor family inside those blocks and with nice generic interfaces. Then one thing that we like a lot from FOSS as well is everything is text files and everything is Git friendly. So try to do that as much as possible. Reduce the amount of block design. Try to have it in text instead. Documentation, also text-based, Markdown or other, and then generate PDFs, web pages, websites from it, but try to make it evolve in the same repo with your design and also versioned. So also text-based, so your diffs are very clear. And then if you use IP generators or any other kind of proprietary tool that generates things for you, the output of those tools, first of all, sometimes you cannot share it openly. Sometimes it's all rights reserved. Sometimes it's also not very Git friendly in the sense that if you change an option, the file will change in many, many places and the diff will not make a lot of sense. So it's better to have scripts to invoke those generators and publish those scripts so people reproduce the work locally. Okay, moving on to other things that we learned from FOSS. So if there are good FOSS tools, that can make your life easier, in particular automate tasks, use them. I'm not going to go into detail. I don't have time to discuss about all these tools. I think many of them will be presented in this forum. They really make life simpler for you, but also they make it less error prone. You will make less mistakes if you automate things. What do I mean by good FOSS tools? It's mostly try to make sure there's a community behind, somebody maintaining the tool. You know, the only bad thing that can happen with the FOSS tool is that it goes unmaintained, and that's unfortunate. So try to identify things that have a bit of momentum, and then, of course, by all means, capitalize on them. Releases. If you have top-level designs, it's good to have a nice page with links to the version binaries and the documentation, including the versions of the tools that you will need to work with that design. And finally, very, very important as well, try to nurture a welcoming environment for the community around your design. Be kind to others, and make sure you have this nice environment where you foster kindness and also enforce respect. You can do that by, respect is like the best line. You can do that with a code of conduct or more informally, but try to make sure that people are always respected. Then a few words on versioning and dependencies. Also from, we know this from the software world, you're supposed to be able to interrogate a program to see what version it is. Same thing here. In a bitstream, you should be able to ask the bitstream what version it is, and also relate it directly to the hash of the commit that it corresponds to. Okay, and this is typically done with synthesis time scripts that will generate on the fly a new HDL stub with the hash, add it before synthesis, and then into place and route and everything into bitstream generation, so that you have a proper hash which is exactly the hash that your code corresponds to. So this is outside of the tree, so it can be automated with a script. And then ideally also follow that approach also for the cores inside your design. So each of them should have an ID and a version, and you should be able to find out what core it is and what version it is. Now, unfortunately, there's no industry standard for this, or there are industry standards which are more or less up-to-date and useful and friendly and lightweight. So people go and invent their own. Here's an example. But again, the bottom line is try to make it possible to identify the ID of what you have deployed. And somehow relatedly, I think packaging is a very good idea, from the Linux distributions world. So packaging in that sense of producing packages which can help you manage versioning and also dependencies. For example, if you have a bitstream and a device driver from a Linux host talking to that FPGA, the device driver version and the bitstream version should be coherent, okay? And you can enforce that through packaging. And you can use this gateway identification I was referring to before to have checks at device driver install time. Okay, a few words on collaboration platforms. By collaboration platforms, I mean GitLab.com, GitHub.com, and company. There are several options. In order to choose, I think it's good to take some decision elements into account. The familiarity and wishes of the main designers. Also, how easy it is for people to create an account and start contributing. And the features of the platform. Notice I am not, for those of you who work at CERN or with CERN, I am not referring to gitlab.cern.ch, which is the private instance, GitLab instance. It's a GitLab Enterprise Edition, not the Community Edition. And therefore, it's hard for us, I think it's impossible for us to give accounts to people who are outside CERN. So it's not a good platform for if you want to have a democratic access to the project, okay? I will have some words to say later about what gitlab.cern.ch is good for, but definitely not for hosting projects in which you want to have a democratic access and very easy ways for people to jump on board. Okay. In terms of features, desirable features is, of course, a Git repository. Issue management is an absolute must. So you must create an issue or have people create issues for every problem, and that's the place where you can track progress on that front. I like wikis. Some people do just with a very good README file. I think README files should be compulsory, a very good README. And in addition, wiki gives you a bit more freedom to have like a single nice entry point for your design where you describe things like contact information, short description, licensing, ways to contribute, and so on. Forums, because, and this is typically not integrated in GitLab or GitHub, but here we use Discourse, but it is very useful. And sometimes the communication that happens over issues and pull requests and merge requests is not enough. And then this relative newcomer to HDL, which is taking the world by storm, CI/CD. So it should be a sign of a high-quality HDL development to have CI/CD for many things, including linting, the synthesis itself, and then the generation of outputs and also simulation, of course. Okay, a few guidelines for CERN members of personnel. When you create an account in github.com or gitlab.com, use your cern.ch address. This is your professional address. Okay. Also for your Git commits, you should use your professional address. As I said already, sorry, wake up. Any questions? Should I turn this off? Okay. By the way, yes, feel free to interrupt me anytime. I think we're doing very well with time, so ask any questions on the fly. So as I said, do not use gitlab.cern.ch to host projects with non-CERN contributors. Use CI/CD for linting, enforcing a coherent and documented HDL coding style. You hear me, right? Yeah. Then test benches of the pass-fail type also in your CI/CD, and packaging, producing actual packages as an output. Now, it's very often the case that you need to run proprietary tools in your CI/CD, okay? Because many of the most popular, for example, simulators, the synthesis tools, they are proprietary. And you are not at liberty at CERN to provide access to those tools to people who are not CERN employees, okay? So here's when gitlab.cern.ch can become useful. You can put in place a mirror with the pull method. So at regular intervals, gitlab.cern.ch will go and fetch your design from github.com or gitlab.com or any other place outside, and then run those pipelines on your behalf with a manual intervention from a CERN employee, so that nobody can claim that there was an automated path from the commit of a non-CERN employee up to the running of a proprietary tool. Okay. IT, by the way, I'm giving you, these links to the OSPO documentation. There is more details in that website, and there is also a link to the IT contacts, so you can get support for putting in place these pipelines. Provide a good README. That should not be an option. It is compulsory in the top directory with a short description, ways to contribute, licensing, and contact information. And then to make sure that you are okay in terms of licensing all your files with a header, or maybe bulk licensing with a deb5 file like in the Debian packages. There is this methodology or these guidelines called reuse from the Free Software Foundation Europe, which is the guidelines and the script that actually checks that you have applied it correctly. So try to use that for making sure that your licensing information is machine readable and checkable for coherency. Okay, a few words on licensing. So first of all, a license is a permission you give to somebody in order for them to be able to do something they would not have the right to do in principle. For example, in copyright law, if I put a text file on the web, copyright law says that by default, it's all rights reserved. People don't have, this is counterintuitive because I put it on the web, right? But people don't have the right to copy it, okay? And they don't have the right to modify it, republish it, and so on. That's the default copyright. If I want to give people that freedom to copy, modify, redistribute, I have to give them a license. This is where I say, I'm the owner of this file, the copyright is with me, and I give you the right to copy it, okay? And maybe in exchange of that right, I'm going to ask you to do something like share back the improvements, and then it becomes like a kind of copyleft type of license, okay? But this is the basic principle. Now, I'm going to, later on, recommend you to use the CERN Open Hardware License version 2 for your FPGA designs. And in order to justify that recommendation, I'm going to start with how we started when we drafted the license. We started, of course, as I explained earlier, capitalizing on past efforts. So software licenses have been very useful. So this is our starting point. It's nice to base your licenses on copyright because copyright law is very uniform across countries. In particular, all rights reserved by default, that's in every country. Then some of these modern licenses, they also include support for patents. That means I publish something and I also promise that I will not sue you for patent infringement if you use my stuff. I mean, it would be a bit extreme or strange that I publish something and then I sue you if you use it, but it could happen. So some of the license texts, the modern ones, include this patent license as well. So there are three licensing regimes, three big families of ways of sharing. One is the permissive regime. If I have a core, or let's talk about software. I have a library, software library I've written in C or C++, and then I share it with you with a permissive license. Then you are allowed to use it in your work, even modify it, and you don't need to share anything back. You could keep it proprietary, you could distribute a binary. This is the permissive regime. If I license my library under a weakly reciprocal license, oh, by the way, sorry, permissive examples of licenses include Berkeley, BSD, MIT, and Apache v2. Apache v2 is more modern than the other two in that it includes a patent clause. Okay. Weakly reciprocal, if I license my library as a weakly reciprocal, with a weakly reciprocal license, like Mozilla Public License or the LGPL, then if you modify my part, you must publish it back. Okay? You can use it in a bigger work, and you don't need to release the sources for that bigger work, but if you change anything on my side, then you need to publish that back, share it back. Okay? That's weakly reciprocal. And then in the strongly reciprocal license, so if I use one strongly reciprocal license for my library, then if you use it and you modify it, you should share it back, these modifications, but you should also share the sources for the bigger work in which you used my library, okay? So the copyleft provision extends to the whole of the work, and the aim is to create an ever-expanding pool of open source, free and open source software. So these are the three licensing regimes, and the examples. The examples for strongly reciprocal include GPL and the Affero GPL license. Now, permissive licensing is relatively straightforward. So you could potentially use BSD, MIT, Apache for your HCL code. It wouldn't be a big problem. Reciprocal licensing is a bit more tricky. There are some issues when you apply the well-known software reciprocal licenses to HCL. One of them is the language. So in a license, you want legal clarity. You want to know exactly what is meant by every term. And there are terms like shared library or dynamic linking or system libraries which don't have a straightforward meaning in the HCL context. So you have to have like a dictionary, and then it's your dictionary. Who knows if a judge would interpret it the same way? There is no equivalent to linking. This applies to weakly reciprocal licenses. It's an issue with LGPL 3. It contains a section 4D in which it is said that if you take my LGPL library and then you make a bigger program out of that with my LGPL stuff in it, and then you distribute it, you should also distribute to your users a way to update the LGPL part. Okay? Then, this in software is relatively straightforward, because then you would distribute a binary of the proprietary part. You don't distribute the sources. And then people can link with an updated version of the LGPL code. Okay? But there's no equivalent to linking in HCL. So this is very awkward and very, very hard to put in place for FPGA designs. Okay? So again, unenforceable or impossible things to comply with in the license, not a good thing. Reciprocity. First of all, what should a reciprocal license do for a hardware design? My intuitive understanding is that if, in hardware, like a printed circuit board, the equivalent of the binary in software is the piece of hardware itself. So if I receive a piece of hardware whose design was licensed under an open hardware license, I would like to have access to the design files. Okay? That would be kind of the equivalent of receiving a binary and being entitled to see the sources. In FPGAs, it would be the bit stream that travels with the design, and then if I receive it, I should be entitled to see the sources. Now, how do you enforce that with a software license? And also, what is the scope of reciprocity? In GPL, you have this notion of system libraries. So going down in the hierarchy of software, you don't have an obligation to share the system libraries. And system libraries are defined in the license text, and when you read that definition, you cannot map it easily to HDL. For example, the basic primitives that you have in FPGAs do not qualify as system libraries very clearly. So that means that you should, in principle, disclose the sources for those primitives. That's also impossible because they are all rights reserved by the FPGA vendor. And finally, yeah, this is what I said, HDL design ecosystem. So when you mix this kind of lack of clarity on the reciprocity scope with the realities of the proprietary tools, then there is an issue in that you're expected to disclose things which you don't have the right to. So moving now to the CERN Open Hardware License V2 is based on rights mainly applying to the design sources. So in the case of HDL, it would be the HDL files themselves. Like all the licenses, it specifies conditions to copy, to modify, to distribute modified or unmodified designs. But because it's a hardware license, it also specifies conditions for making the hardware out of those designs and for distributing the hardware. This is just to reassure you. I was a co-author, but there were two very competent lawyers in the team, so it's a legally sound license, Miriam and Andrew. And it comes in 3 variants. So it aims at being a one-stop shop for your licensing needs, whatever type of sharing regime you want to use. There is a permissive variant, a weakly reciprocal variant, and strongly reciprocal variant, and they behave in exactly what you would expect, in the way that you would expect intuitively. Okay? So how do we cope with the challenges I just described? First of all, language, of course, that's easy. It's a hardware license, so all the terms talk to hardware designers, and they are easy to interpret in an HDL context. Linking, there's no equivalent of that section 4D of LGPL v3 in the weakly reciprocal variant of the license, so the one that you could potentially compare with LGPL. Reciprocity, we have this clause that you can ask a URL to be engraved in the product, and that gets preserved even if the product changes hands many times. So you can ensure that the final receiver of that hardware gets access to the design files. And also in terms of the scope of the reciprocity, moving up, we have the notion of product, where the reciprocity obligations stop. And moving down, we have the notion of available components. So for example, if I have the design of a mouse, this is not a good example, with a wire, okay? And then I connect it to my laptop. If my mouse is open hardware, the design files of the mouse, what you make out of those design files is defined as a product. So the product is the mouse, not the connection of the mouse plus the laptop. Therefore, only the mouse design files need to be released. You don't need to release the laptop design files just because you connect it with a wire. In terms of available components, going down in the hierarchy, we try to reflect common practice in the hardware world. When you design a PCB, you don't need people to disclose the details to make the resistors. Resistors are just things you can buy. So resistors are available components, and by defining this notion of available components, a bit analogous to system libraries in software, we can stop the obligations to share there. And we have defined for FPGAs that the components which are shipped with design tools qualify as available components. This solves the problem of these primitives from FPGA vendors that you could not possibly share because you don't have the right, but you would be expected to share if you were using a license such as GPL. Okay, this is the same thing pictorially. You can see an example where you have your project in VHDL, some sources licensed under the open hardware license, you mix them together, and then depending on the variant of the license that you're using, if you're using the permissive license, you don't need to disclose anything. If you're using if this file here was using the W variant, the weakly reciprocal variant, then only modifications to that bit would need to be disclosed. And if it's a strongly reciprocal variant, then all the complete work, including your contribution, should be disclosed. Okay, the hardware and HDL very often come with software and documentation. You should use appropriate licenses for that. So we have seen in the previous slides a few examples of good software licenses. Go to your favorite guidelines website or your local OSPO and see what's the best license for your software. This is an independent choice from the choice of the license for the HDL and the hardware. And for documentation, CC BY and CC BY SA are good licenses. So BY is just attribution, and BY SA is attribution and share alike, a bit of like a copyleft for documentation. Okay, so very quickly concluding, most of these best practices, like if you take the concepts and you don't focus too much on the tools, on the ways of doing things, are largely uncontroversial. Tooling is a matter of taste. And here are some contact information for the CERN OSPO, including the technical website. We have a lot of information about FPGAs. Also, the forum, if you want to ask questions publicly, or if you want to address questions to us in a bit more private setting, the email address. So don't hesitate to get in touch if you want to discuss further. Thank you.
Thank you so much for the presentation. It was very interesting. Clearly, you have thought a lot more about licenses than the average person. Mm-hmm. Thank you for that. My question is, you had these 3 levels of the CERN license with varying levels of reciprocity. So I wanted to ask, which level does CERN publish its work under, and why?
That's a very good question. The OSPO decided, so we were in this drafting hackathon a few weeks ago, and we decided not to make any specific recommendation on any of the 3 families. We leave it up to the project, because sometimes we also had to cover the software case, right? And one of the first elements to take into account is your ecosystem. You know, we have many Python projects which use BSD, I think. And you go there and you say, okay, I'm entering this project and I want to be a good citizen in this project. And the license is a bit like the constitution of the project. So you want to just be good to the people who are accepting you as a new member, and you go with that license, right? So there is no default in the OSPO recommendations. I can tell you in the section I lead, we decided to go with W, which is, I think, a good compromise by default. But always considering for every project, it's a discussion that starts kind of from scratch. And we have in the back of our minds that we have this W default, unless there is a reason not to go that way. But to answer your question, there is no recommendation, which is a CERN-wide recommendation for one of the 3 variants. Very early on in the drafting of version 2, we noticed that it wasn't possible to cover all the cases, so we left it open, and that was one of the reasons why we drafted 3 variants of the license.
Okay, thank you so much. Second question, as someone who currently publishes HDL under the BSD license, what would be the benefit of using the CERN permissive variant?
As any modern license has a patent license as well. So I explained, in fact, there are 2 patent sections in the open hardware license in the 3 variants, actually. One says that if I publish my HDL code and you take it, I am promising not to sue you for any use of that code. So it reassures you as the licensee that I, the licensor, am promising not to sue for patent infringement. This is not in BSD. And also, there's another clause that says that if you sue me, all your rights, all the rights I'm giving you to copy and so on, they disappear. If you sue me for this particular design that you're using, Okay, so this is a feature of modern licenses because patent became a big thing. Patents became a big thing also in software, at least in the US, way after the BSD license was drafted. So modern licenses typically contain a patent clause. So that would be one advantage. You could also have it with Apache v2, which is a purely software license. But if you decide to change your license, I think going for a hardware license makes sense also for the language, because people can relate very easily to the language. And it's a relatively simple license text that is easy to understand.
Okay, thank you.
Hi. Also, thank you for the great talk, first of all. So this is regarding the licenses again first. So we have been using this solder pad license, right? And I think now it's not maintained, or somehow there are some. It's not that also not that flexible. What you have at CERN, this
Yes.
model that you have, that you can be permissive or not permissive. You can choose,
Yes.
right? So what are your let's say your remarks on all the solder pad license? One thing that is the first part, and secondly maybe an question about that, the final product. Let's say we want to build hardware plus the software and documentation, that it can be an OSHWA certified, so open source hardware certification, right? If we want to reach that goal, what would be your suggestion for the choice of licenses?
Yes.
Thank you.
Okay. So the first question, SolderPad. SolderPad is a very good license, and the reason I think it's very good is that it's done by Andrew Katz, so one of the 3 authors of the CERN OHL. Before he worked on the CERN OHL v2, there was an appetite in some circles of open source for something which would be like the Apache v2, which is the modern permissive license, but with terms that you could easily relate to if you're doing hardware design. Okay, so he provided a translation, a dictionary of the terms, and I think that's a very useful license. I don't see any clear reason to go with CERN OHLP or SolderPad. Their effect is very, very similar. And I think it is supported. I think if Andrew identified a problem with the license, he would evolve it. I mean, he's still active. The license is a service. He provides that to the community, and it seems to be working. It achieves what it says. It's a permissive license, so I don't see any problem with using it. It's just that when we drafted CERN OHL v2, we said, let's make a one-stop shop for every need. And since we had that drafting opportunity, and it was like a low-hanging fruit, the permissive variant was the easiest. The hard ones were the other 2. So we did it just to cover all the ground inside the CERN OHL family. The second question is about hardware certification. This is an initiative of the Open Source Hardware Association, and they give you guidelines in their website that you can follow, guidelines for licensing HDL, guidelines which include the CERN Open Hardware License, guidelines for licensing your software, your documentation, etc. So I think it's a very good thing to certify your hardware, and there are guidelines there, and they also have a forum where you can ask if you have any doubt.
Hi. So I wanted to ask, thanks a lot for the talk, very interesting, by the way. I wanted to ask about all the things that we may have been doing over the years that we have published in GitLab or gitlab.cern.ch, maybe single programmer work or whatever. We didn't bother to put a license on it. I understand by default it's unlicensed, so we are still in time to make it. It has not yet been opened yet and released. Yes. We would have to do this active part of taking this same thing, even though it's already available and possibly open to everybody and
this
get
is typically a process where the OSPO can help you at CERN. I don't know if you're at CERN, but
no, I'm a user. I'm a user. Okay. Yes.
But probably if it's something related to CERN, the OSPO can help. But anyway, even if you published under whatever license, you can always do your due diligence. That means identify the copyright holders and decide to relicense under any other license. Okay. The only thing you need is to contact all the owners of copyright of IP in that design base and make sure they agree before relicensing or before licensing to begin with, because as you say, maybe some files do not have a license yet. another important point is that, yes, if you don't include a header, by default it's all rights reserved, which means people don't have the right to copy it. Okay, I know you're probably not going to sue anybody, but just for your information, when you open source, of course, you want people to be able to copy, so that's the main reason to put a license in there. And then wherever it is, on GitHub or on gitlab.cern.ch, you can always relicense, go through the due diligence, and publish properly in a place as a good basis for future sharing.
Okay, thanks.
Yeah.
Hello, thanks for your talk. Actually, it was very insightful. From the industry perspective, at least from the software part, we have always concerns about GPL licenses, particularly the transition from B2 to B3, because basically the B3 talks about devoicization. So basically, they want to avoid that kind of activity that this company was doing. I don't know if you are aware of that.
Yes, I know.
Okay, so in terms of the, let's say, not that permissive licenses in the open hardware license, so basically, how strong they are with respect to that point? Because at least when I have to deal with customers, basically avoiding the B3 is a must, even if you are, for instance, open sourcing.
Yes.
So basically, I just want to see if the scope of that in that term.
Yes. There is no, how would I say, there is no clause in the S variant. The S variant is a strongly reciprocal variant, the one you could compare to GPL. There is no clause of the type what you have to do when you install something, which is what you have in the GPL v3. But on other respects, it is strong, because that's the aim of this variant, right? In that if you have an FPGA, our goal when drafting was the following. You have written a core, an HDL core, and you license it with S, with the S variant. Then people use your core in an FPGA design, okay? And the goal of the license is to make sure that the whole of the design is published. That's it. Of course, there are, as I said, we had to work a bit around the basic primitives of the vendor, because you are not entitled to share them. They belong to the vendor, the AMD Xilinx or Altera Intel and so on. But all the rest should be shared. If you don't want that effect, then you should use another variant of the CERN OHL. Okay? So it is strong, and because it's meant to be strong. Yes.
Thank you very much for your presentation. I was wondering, as these licenses are like international, in case of copyright infringement, how do you manage this kind of stuff? Will it be in the licensor country, territory, I would say, license stuff, or it will be in the user country?
Yes.
You will, how do you manage this kind of features?
Okay, I have learned a lot of legal stuff by working with lawyers for many years, but I don't have an answer to that. The answer I have is that CERN does not manage that. This is an issue between the licensor and the licensee. CERN is making this text available, and then if anybody as a licensor wants to use it as their license, then the kind of obligations are between licensor and licensee. So if I feel as a licensor, now I'm stepping out of CERN and I'm saying, okay, I'm a licensor, if I feel that you're infringing my rights, then I might want to sue you. And my intuition is that I could decide where to sue you. I don't know if there is a default for the question you were answering, which is the country where the infringer is, or the country. I don't know. Frankly, I don't want to give an answer, because I could ask it, and it's a good question. I could ask it to one of our legal experts. And if you want to remind me, feel free to post a question on the OSPO forum or in the FDF forum, and I will make sure it is answered.
Last question.
Hello, that was a very nice talk. I would like to know whether there is any preference or recommendation when it comes to the language, whether it should be VHDL or Verilog or System Verilog?
Yes. No, I don't think there is any CERN-wide recommendation. I know that in our section at CERN, there was more and more people feeling that System Verilog was very nice for verification, and they started writing test benches in System Verilog. We have a big legacy of VHDL code, and we are still developing, designing VHDL cores. So we end up in a situation, and this is kind of the negative angle of this, where we don't have any free and open source software tool that we can use to verify these circuits. Because if you want to do mixed language simulation, this is one of the missing bits in the free and open source software ecosystem. So yes, that's an issue for us. But to answer your question, there is no general guideline at CERN for language.
Okay, just because you are one of us.
Yes.
No, it's a follow-up question on this. So as a thing we were discussing before is that, like, for VHDL you have different versions. You have VHDL 08, VHDL 19. And if you want to just release a module as open source, you want maybe to make it like compatible with many vendors. But these many vendors use different features of VHDL 08 or VHDL 19. They don't support the full language. I was wondering whether there is a discussion inside CERN on how to proceed with this.
Mm-hmm. I think we have a very big VHDL expert in the room. I think I wouldn't dare answer that question with Tristan in the room. So maybe give the Tristan, for those of you who don't know, works at CERN, and he's the author of GHDL, which is the most used free and open source software VHDL simulator in the world. So he knows VHDL inside out.
So we have a very simple answer. It's because we are using quite old FPGA, like Spartan 6, which are supported only by ISC, which only support VHDL until 1983. We stay with VHDL 1993, which is supported by everyone. Simple. Okay, and for System Verilog, we are only using mainly for simulation. And then we are a little bit, we have more choice.
Thanks for the answer.
Yeah, I was afraid that would be the answer. Okay, so thank you very much, Javier. It was really good.